Okay, so we want to go to next chapter. So I a little bit deviate from what is written in the book. I just want to motivate you the very important topic of derivative of functions. So chapter 2, a derivative of functions. Okay, so first I want to motivate you about the very important concept of derivatives. So probably, I don't know, have you heard about derivative of functions before? But in principle, this is the new lesson, completely new lesson, and it's very, very important. What you learn from chapter 2 onwards would be very helpful if you want to take math 4 as well. Okay, so please pay close attention to this topic so that you can actually learn it in a good way. So today I don't want, of course I will give you a lot of information, but more or less these are motivating examples, and at the very end probably I will define the derivative of a function. So in the 17th century, actually, two scientists, one of them was Gottfried, Wilhelm von Leibniz, so we know it by Leibniz simply. He was a German mathematician and philosopher, of course. And then Sir Isaac Newton. They were thinking about two different problems. One of them was just a pure mathematical problem, and the other one, as you know, it was mainly physicist. It was interested in actually physical questions. Okay, I want to talk about these motivating questions. So what was the question Leibniz asked himself? What was the question that Newton asked himself? Okay, so for the Leibniz, I think it's more or less easier to start with. Okay, so the question that Leibniz asked himself was a very simple question. He asked himself, if I have a curve and then I want to find the equation for a line which is tangent to the curve, what we should do? How should I calculate an equation for the tangent line to the graph of the function? So for example, if I want to make it more clear, so let me try to draw better pictures here. So let me start from here. So assume that you have a coordinate system. Okay, so this is your x-axis, and that's your y-axis. And then you have a function, and then you have drawn the graph of that function here. So assume that this is the graph of your function. Let me call my function just simply f of x. This function can be any function that you like. For example, f of x is equal to x squared. F of x is equal to, I don't know, x plus 1. F of x is equal to x squared plus 1 on anything. So you draw the curve, and you draw the graph of the function, and then you get something like this, or one portion of that. And then you have a point on the graph. So say this is your point. And then assume that you know the x-coordinate of the point as well. So f of x is given to you. The formula for f of x is given to you. And some point on the graph is also given to you. Assume that this point is given to be A. Okay? And then the question that Leibniz wanted to answer is that how can I find an equation for the line which is tangent to this graph at this point on the graph? Yes? So if I can draw it here. So let me try to draw the tangent line. So he was thinking, how can he find the equation, an equation of this line? Yes. So this line, I hope that I can give you the motivation. So this line is tangent to this graph. Yes. So every one of us has an intuitive understanding of what a tangent means. So it touches the graph but doesn't cut it. So it touches the graph at one point. And then he wanted to answer this question, how he can find an equation for this green line if the formula for the function and the value for a are given to you. So that was the question. Yes. Okay, so keep this in mind. I want to make sure that you remember everything that is needed for this case from Math 2C. Okay, so I will start writing an example and then I will remove this example. I just want to make sure that you remember this. Okay. Determine an equation for the straight line that passes through the point for example, I call it A with coordinates -1 and 3, whose slope is -4. So I hope that you remember this was a typical problem when we were talking about these kinds of questions in Math 2C. We want to determine an equation for the straight line for which the slope is given to you, and one of the points on the line is also given to you. Okay, so we want to see how we can find an equation for this line. So if you remember, the solution was something like this. We would say that an equation of a straight line is an equation of this form, kx plus m. If I want to determine an equation for this straight line, it means that I need to know the value for k, I need to know the value for m. The value for k, which is called the slope or the gradient of the line, is directly given to you in this problem, which is -4. So instead of k, I can replace it. Instead of k, I can put -4, and then I have x, and then I have plus m. So still this problem is not complete because I need to determine m as well. This is why they provide you an extra piece of information in the question itself and telling you that this is supposed to pass through this point. This line is supposed to pass through this point. So it means that the coordinates of the point will satisfy the equation of the line. So it means that I replace y with 3, it becomes 3 equals to, I replace x with the x coordinate, which is -1, and then m is left for me. And then this is a very simple equation. I can solve it and find m. Yes, so what can I do? I can write 3 is equal to -4 times -1 is 4 plus m. Then I move 4 to the left. 3 minus 4 is -1 is equal to the m. And when everything is clear, the answer that you need to provide here is y equals to -4x plus -1, which is -1. And that is the answer. So this is a prototype example that you need to have in mind from Math 2C. Yes? If I ask you to find an equation for a straight line, I give you the slope, I give you a point, then you immediately do this and are able to solve this problem and find the answer. Okay, So let us now go back to the question that Leibniz asked, okay? So here, if I want to find the equation, an equation for this green line, what I need to have? I need to have two pieces of information, according to this problem. I need to have the k value. I also need to have 1 point on the green line, okay? This piece of information is actually more or less clear that I have it here. Because why? Because this point, I told you that A is a given number to you. So you have this, okay? And then let me call this point T, because this point is called the point of tangency. Okay, I will write them later. So the point A has two coordinates. X coordinate is given to be A. But can you tell me what would be the y coordinate in this case? I don't know. Can you talk to me through Zoom or not? Can you? Okay, so if I have a function, let me talk for you. If I have a function here, if I have the x coordinate to be A, if I ask you find this height, find the y value, you need to replace the x in the function with the x coordinate, which is A, and calculate that value, then you will get the y coordinate, yes? So what I do is I replace x with A, and I will get f of A. Yes, hopefully this is understandable. So if I have a function, this is the x coordinate. Because this point lies on the graph as well, so it means that by plugging this value instead of the x for the function and calculate it, I will get a number. That number is the y coordinate of this point, because this point is not only on the tangent line, but it is also on the graph of the function. This point, so if you don't mind, let me change the notation here. Instead of A, let me write T, because this is the point of tangency. This is the name of this. It's a point at which the line touches the graph. That's called the point of tangency. Okay, so it means that this part of the problem is more or less clear for me. If I give you A, you put it in the function, you calculate f of A, so it means that you have this point, okay? So the main problem here is not finding a point. That was an easy task, yes? The main problem is how to find this k value. In this problem in Math 2C, the k value was directly given to you in the problem itself, so you were able actually to replace the k value, the k with that value. But the point is how to find the k value, okay? So if I want to make everything short, to answer the Leibniz question, I have one problem to solve, and that is finding the k value of the tangent line. Yes? Okay, so if you don't mind, let me now, no, we don't need to remove it, we have a little bit of space here. The idea that Leibniz started thinking about it is that, okay, let me choose a point a little bit further here. So for example, let me go a little bit forward and choose another point. So assume that I go h units to the right, okay? So this length, assume that this length is h units. And when I reach here, this was A, I add h to it, this point becomes A plus h. Okay, and then let me find another point corresponding to this point here on the graph. Yes, so something like this. And then let me call this point now point A. If I ask you what is the x coordinate of this point, it is easy. You see it here. It is A plus h, yes? So I put A plus h here. And if I ask you what is the y coordinate, you just answer the same, yes? You would say that this point is lying on the graph. So if I want to find the y value, I need to replace the x of the function with this value, and then I get the y value of this. So it becomes f of A plus h. Okay, and then he considered this line. Of course, you see that this line is not the tangent line, it's clear. It's called the secant line, a line that cuts the graph more than one point. Okay, so this is called, the green line is called the tangent line. And then the other one that I just drew, the red one, is called the secant line. Okay, so, and he calculated the slope of this red line instead of the slope of the target line, the green line. Okay, I hope that you remember a formula again from Math 2C, so that how we can calculate the slope of a function of a line for which 2 points are given to you. So I have these two values for t, I have these two values for a, and this is the line passing through the point t and the point a. I want to find the k value. Okay, so if you remember, there was a formula in Math 2C that the k value is the difference between y's. If you remember, we showed it with the delta y divided by delta x. So this is the formula. So if I want to write it for this one, so the k value of the red line, so let me put TA here, meaning this is the k value of the secant TA. TA is this secant line, and I am showing this I am writing this to denote the k value of this secant line. So this becomes equal to the difference between the y values. So it becomes the y value for the point A minus the y value for the point T, divided by the x value of A minus the y coordinate, the x coordinate of T. Okay. Just may you say something to me on the Zoom so that I can make sure that you can say something to me if you don't understand?
Yep. Hi. Hello.
Okay, good. So it means that if you have questions, you can ask. Okay, I'm now relieved. Okay, so now let me just put these expressions inside. So what will happen here? Instead of y of a, you see, this is the y coordinate of a. So this is f of a plus h minus y of t. The y coordinate of point t is f of a. So you see, instead of ya, I put this minus sign. Instead of yt, I put this. And then divided by x of a. The x coordinate of point A is a plus h, so I put a plus h, minus the x coordinate of point T, which is a. Okay? So if you see this a and that a are cancelled, but I cannot simplify the numerator anymore unless the function is given to you. I am assuming, I am pretending that the function is given, because I want to talk about a general situation. But in practice, so here right now we don't have any knowledge about the formula for f, so I have to keep it in that way. And then what I got is this: k of a ta is equal to f of a plus h minus f of a divided by h. Yes? This is very, very simple. You see, you don't need to be brilliant to be able to calculate the k value of this secant line. Of course, we know that this is not our target. Our target was to find the slope of this green line. And you can immediately see that these slopes are not the same. Yes, the slope of this red line is smaller than the slope of this green line. Okay, so I cannot consider this as the slope of the green line, even though this is the exact slope of the red line. Okay, but now the idea is this. instead of going to this point, let me make this length h a little bit smaller. Okay, might be I was a little bit careless. So let me change my color and then try to make it a little bit smaller. I will keep this picture, but let me make this h a little bit smaller this time. Let us see what happens. Okay, so instead of having that value for h, let me go just like this. This time, assume that this is your h, and this is a, and then this would be a plus h. Okay, now let us do the same thing here for this line. So then what happens here? If I do the same thing here, I will get this point. It means that this point, instead of now this one, this would be the point A now, okay? And then, of course, the same thing. This is A plus H, and this is f of A plus H, okay? But now let me draw the new line. So what happens here? That's the idea. I hope that this is motivating enough. So if I draw this line now, even though this is still a secant line, not a tangent line, but there is a nice idea behind this. You see, what is happening for this orange line is that still this orange line is not equal to this green line. It's still a secant line. But if I calculate the slope of this, which I have already done here, because that's the same value, then the slope of this orange line is closer to the slope of this green line. Yes, if you consider the slope of the red line, the deviation from here to here is much more than the deviation from the slope of this orange line to the green line. Okay, so it seems clear intuitively. I'm just talking intuitively. It seems clear that if I make h even smaller, then what happens? Instead of having this point here, this point will be somewhere here. And if I draw that line still is not the green line, but it is closer to the green line. Yes? So this idea, hopefully for you, is clear that if I make this h smaller and smaller, this point A becomes closer and closer to the point of tangency, and the secant line becomes closer and closer to the tangent line. Of course, the problem is that if I make it exactly 0, there is no point for that, because if I make it exactly 0, the point of that tangency and the point of A are not 2 points. They are exactly 1 point, and that cannot solve my problem. Yes. So the principle is this. I can make this h smaller and smaller, but I am careful that don't make h equal to 0. And then I would say to myself that this secant line, by making h smaller and smaller, will start turning around this point of tangency and becomes closer and closer to the tangent line. Yes? So this means that the idea that Leibniz realized is that if he takes the limit, if he takes the value for the k value for the secant and take a limit and send h to 0, intuitively he convinced himself that this would be the k value of the tangent. Yes, so that was the idea behind the solution, Leibniz solution for the problem. So he, by drawing some picture like this, he said to himself, my goal is to find the k value for the tangent line. First, I consider the k value of the secant line. And then I find the formula for the k value of the secant line. But then using my geometric intuition, I realized that if I make this difference smaller and smaller, what is happening? The second point will start moving on the curve, and then this secant lines becomes closer and closer to the tangent line. So intuitively, if this h is extremely small, I reaches to that point that I cannot differentiate between the secant line and the tangent line. So the only thing is that I need to make sure that h is not 0. And if you remember the last topic of the previous session, we talked about limits. Yes, when I write the limit of a function and send h to 0, it means that h is very, very small. It's very close to 0, but it is not equal to 0. And that was the crucial point, okay? So hopefully, I just want to make sure that everyone actually understood somehow this. This is intuitive picture. This is not a very rigorous mathematics. Making these things rigorous is a little bit hard and beyond the scope of this lesson. But it is not that hard to understand intuitively that the idea as it is at least correct. Okay, just I want to wait some seconds to make sure that you understand everything. If you have questions at this stage, please let me know.
You said it could become more rigorous. How do you mean it can become harder?
No, if it becomes more rigorous, it means that in principle, this is the definition of a tangent line. Yes, so we need to understand the limits of functions first from mathematical points of view. And by the way, at the time of Leibniz, even Leibniz didn't know about these definitions at that time. These definitions comes nearly 250 years later. Okay, in principle, I need to, because I am relying on your intuition about the tangent line, yes, because I have drawn a very simple curve for you, and then I ask, okay, this is the tangent line. I'm assuming that you know the tangent of a line to a circle, and then you can just understand intuitively what's the meaning of tangent. But if I want to be mathematically rigorous, I need to define what do I mean by a tangent line in the first place. Okay, but if you don't consider that, everything that I have done is intuitively understandable and precise. It's not bad actually that much. But if you want to be very, very strict, then of course this is not a very rigorous mathematical way of presenting this. But forget about that. I just want to understand. I want to make sure that you understand this intuitively. That this idea that I start with the secant line and then make this h smaller and smaller, intuitively I see that the secant line is getting closer and closer to the tangent line. So I would say to myself that if I take the limit of the k value for the secant line and send h to 0, sending h to 0 means, based on what we learned before, means h becomes very small, but not equal to 0. If you remember, I emphasized on this part when I was teaching limits. And that is good, because you see that h here is in the denominator. H cannot be equal to 0. And that is very good, that when I send h to 0 using this symbol, it means that h is not equal to 0. Okay, now, any other questions? Okay, so now what I do, I will take this k of ta away and put this expression inside, and I get a formula. And that formula somehow is the formula that Leibniz came up with. So here I would say k of tangent is equal to the limit of f a plus h minus f of a divided by h goes to 0. So this is the formula that he discovered for the k value of the tangent line. So this is why in the previous chapter, we learned how to simplify, how to calculate limits. And then you see that this limit is always a problematic limit. Yes, because the denominator is h, and I am sending h to 0. So it means that always and always, when I am dealing with this limit, I have problems. I need to solve it. So then you need to use tricks and techniques that I taught you in the previous chapter to be able to calculate these limits. Yes, so that was the whole point of having the limit lesson at the very end of chapter 1. Okay, now let me give you a practical example. And I want you to listen carefully to understand this. This is a very, very important example. I will talk about this Newton's perspective later, okay? Okay, so this is a very important example, but simple one. So example, determine an equation for the straight line that is tangent to the graph of the function say, let me keep the function simple. F of x equals to x squared, that's enough. The graph of the function f of x is equal to x squared at the point on the graph whose x coordinate is, say, 2. Okay, so that is just a very simple example of this problem. I have a function. If I draw the graph of this function, it is a curve. Then I choose one point on the graph whose x coordinate is 2. My goal is to determine an equation for the line which is tangent to the graph of this function at that point. Yes, so for example, if I want to give you some ideas, I can draw the graph somehow, because this is a famous graph, y equals to x squared, yes. You know that that would be a parabola. So if I cannot use GeoGebra right now simultaneously, but you can do it yourself. There is an actually a command in GeoGebra that you can draw tangent lines, yes. So assume that I try to do this. So if I give 1 to this, I want to draw the function, some ideas. So if I give 0, it becomes 0. If I give 1, it becomes 1. If I give 2, it becomes 4, yes. 2, 3, and 4. So do you remember something like this was the graph of my function? Yes, something like this. And then I also have the same part here. So this is roughly the graph of this function. Then I want to find the point of tangency. It is mentioned that the point on the graph whose x coordinate is 2. So it means that if this is 2, I go up, and this point is the point of tangency. So what is the point of tangency? Its x coordinate is 2. Its y coordinate is 4. And then I want to draw the tangent line here. My point, assume that this is your tangent line, something like this. Okay, I want to find the equation for this tangent line. This is a very bad picture, but if you use GeoGebra, you can improve the quality of that. But roughly speaking, that's the idea. I have a curve, I have a point on the curve, and I want to find the equation of this green line, the tangent line to the curve. Because you see that if I change this point to another point, then another line would be tangent. So every point has its own tangent, okay? Okay, so let us do it together. If I want to solve this problem, I want to find an equation for the straight line. But what I reminded you about how to find an equation for this. So you need to say to yourself that the equation of this line is of this type, is equal to kx plus m. Okay? But you need to find k and m now. These are your question marks. The equation of this question mark is of this type. You need to find k and m. Today, we learned how to find the k value for the tangent line. You couldn't do this up to this point. Now we know how to do it using this Leibniz formula, okay? Okay, how can I do that? Let me write the formula first to memorize that, yes? So k value of the tangent, so I don't need to write tangent anymore because this is the only line that we have. So the k value is equal to the limit. Let me write the formula to memorize it. F of a plus h minus f of a divided by h goes to 0. Okay, so after writing the formula, I start plugging the values in. Can you read the text of the question and tell me what would be the value for a here? You can see it also on the picture. You see here, if I want to tell a that I have used here is the x coordinate of the point of tangency. Yes? So here, a is also the x coordinate of the point of tangency, which is given directly in the problem to be 2. So instead of a, I put 2. So this becomes f of 2 plus h minus f of 2 divided by h goes to 0. Okay, what I need to calculate now is f of 2 and f of 2 plus h. These things I need to calculate. F of 2 is very simple. How should I calculate f of 2? It means that go to the function, replace x with this value. Okay, so if I can calculate it on the side of the paper here. So f of 2 is equal to 2 to power 2, which is equal to 4. So f of 2 is 4. But sometimes I see students make mistakes here. This is also very easy. If I told you before that a function is like a machine, it takes an input and gives you an output. Yes, the input is denoted by x. You need to read and understand the output. The output is the square of the input. If I put x in, it square it and give it back to me. So now here, this will play the role of the input of my function. Okay, and the function squares the inputs. So if I give 2 plus h to this function, this will square it and give it back to me. Okay, so if I want to answer to write this, this becomes the limit. Instead of this expression as a whole, I would write 2 plus h to power 2 minus, instead of f of 2, I calculated here, it is 4. So it is minus 4 and divided by h goes to 0. Okay, then the problem is done. This is the previous chapter problem. We learned how to simplify these limits. So I need to simplify the numerator as much as possible. So there is one way to do this. Not the only way, but it is one of the ways. I expand this using the quadratic rule. It becomes the first one to the 2, which is 4. 2 times the first one times the second one, which is 4h. And the second one to power 2, which becomes h squared. And then I have a negative 4 here. And then divided by h goes to 0. Even though I emphasized a lot, don't throw this limit away. Some of you did it in the exam. Of course, I was generous to give you the marks, but this is essentially wrong. You need to keep this limit every time, but at the very last, you need to drop it, okay? So, okay, here, 4 and 4 are canceled. Let me clean this part and write the rest of it here. Okay, and then let me write it here. So this becomes the limit 4h plus h squared are left. In the denominator, I have h goes to 0. And I think most of you could solve these problems in the exam. So if I want to solve this, what should I do? I should factor h out. So this becomes 4, this becomes h, and then I have h goes to 0. Please be careful. You see, I am just copy and pasting this. Okay, so we found the k value to be equal to 4, the k value of the tangent. So it means that this k is now 4. So up to here, I have this partial answer. It is 4x plus n. But of course, this is not finished. I also need to find n. But you know what to do, yes? Because you learned what to do in Math 2C. I have a point here. You see, this point, the x coordinate is 2, the y coordinate is 4, and you see that this point also lies on the tangent line. So it means that the coordinates of this point of tangency should also satisfy the equation of the tangent line, yes? So it means that I go here and I replace y with 4, and then I replace x with 2, yes? So multiplied by 2 plus m, then 4 becomes 8 plus m, and then m becomes minus 4. Finally, what you need to provide as the answer is the whole expression. So y is equal to 4x, and instead of m, I plug minus 4. So my picture here is not that good, but if you draw the graph of this function with GeoGebra and use the tools there to draw the tangent line at this point, you immediately and draw the graph of this function, you will see that this function is exactly the line that you have here. Okay, so if I want to summarize that, this problem it's a prototype problem. I really want you to understand this problem in a very good way. And that the structure is always the same. A function is given to you. So this function might be different functions, x squared, x cubed plus x squared, or whatever. And there is a point given to you as the x coordinate of the point of tangency. And then you are supposed to find an equation for the tangent line. The first thing that you need to do is to use this formula. This formula is given to you in the formula sheet, but I really want you to memorize that. At least you can cherish the soul of those guys, because all the technology that we have, I will talk about these things a little bit later, so highly depends on this mathematical curiosity. There were no iPhones, no electricities if this equation was not there, okay? So here, and then if you want to solve the problem, use that formula, find the k value first. So you need to improve your skills in calculating this type of limits. We will practice more. And after you found the k value, you plug the k value in the general formula and use the other extra information given to you in the problem to find m. When k and m are found, it means that you are done with the problem. Okay, I just want to wait a little bit for you to see that if the process is clear. And then, of course, I want to give more examples. Any questions? Okay. And then to save time, you see, calculating m value was always easy. That's actually a Math 2C problem still. So I want just to practice to be able to find this k value. So I will give you different functions with different points of tangencies, and then I will ask you to find the k value of the tangent line, okay? Because that is the tricky part. You see, this part is just as Math 2C problem. Okay. So let us do some exercises, some practice to improve our skills in calculating the k value of the tangent line. So far, if somebody asks you what this limit is useful for, you would say that this calculates the k-value of the line tangent to the graph of a function. That is the role of that formula. So let me clean everything here. So today we've just practiced a little bit more about finding this k-value. It means that it's a practice in calculating limits, and then you need to use the skills that you learned in the previous chapter. So let me write example. In each case, determine this the slope of the tangent line to the graph of the given functions at the given points. On the graph of the function. Okay. So number one, let me start with simple one. So I have f of x equals to 2x squared plus 1. And let me take the point to be 1. Okay, what would be the y-coordinate? I put 1 here, it becomes 3. So let this point be the point of tangency, 1 and 3. Okay, I just want to find the slope of the tangent line. Let me repeat everything for you here. What we need to do, I need to write a formula. So let me change my color here. So I need to write a formula. So the k-value has a formula. It is equal to the limit. The name of my function is f, so I would write f of a plus h minus f of a divided by h goes to 0. First thing that you need to understand what is the meaning of this a. A is the x coordinate of the point of tangency. In this case, it is 1. Yes? So I would write it, I replace a with 1 at the first step. So it becomes f, instead of a, I put 1. I have h, and then I have minus f of 1, and then I have divided by h goes to 0. The next step is to calculate this one and this one. This is very simple. So let me just do them in one place. So, okay, so this becomes the limit. H goes to 0. Don't be lazy to write this limit sign notation. The denominator is h. Okay, what is the meaning of this function? What is the role of this function? The function takes an input x from you, square the input, multiply it by 2, add 1 to it, and give it back to you. Now you have given 1 plus h as the input of your function. The function will do exactly the same thing on this new input, meaning it squares your input. So your input is 1 plus h. It squares your input, multiply it by 2, and add 1 to it. Okay, I just want to wait a little bit. Everybody understands this? Good. And then I calculate f of 1. What is f of 1? This is the same function, do the same thing, but the input now is equal 1. So 1 is squared, which becomes 1. It's multiplied by 2, which becomes 2. 1 is added to it, it becomes 3. And of course, that 3 is also there. So it's minus 3. So then you don't need to worry about anything, just concentrate to calculate this limit. And I told you that this limit is always problematic because the denominator is h and I am sending h to 0. Okay, so it means that it is inevitable. You have to simplify. There is no shortcut for this limit. So this becomes the limit. What I do, I have this one to power 2 and then multiplied by 2. Don't make mistake. You are not allowed to multiply 2 first and then a square. The priority is with the exponent, with the power. So I need to keep 2. I use quadratic rule to expand this. This is the first one to the 2, which is 1. 2 times the first one times the second one is 2h. The second one to the 2 is h squared. And then, of course, it is easy to see 1 minus 3 is just minus 2. And then I have h. h goes to 0. Okay? And then I calculate this, simplify this. I multiply 2 inside, so it becomes 2 plus 4h plus 2h squared. I multiply 2 inside in all the terms. And then I have minus 2 at the end. And then you see that I repeat it again because I saw many of you were lazy. This time I will not give you the full mark. You need to copy and paste this limit all the time until the very last step. Okay, these 2 and 2 are canceled. And then what is left for me is the limit of 4h plus 2h squared divided by h. h goes to 0. And I hope that you have enough experience how to calculate this. You immediately see that you can factor a 2h out. So I factor a 2h out. From this one, 2 is left. From the other one, h is left. And in the denominator, you have h, and h goes to 0. But then this h and that h are canceled. So this becomes the limit of 2 plus h goes to 0. And now at the very last step, when I want to replace h with 0, I have to drop this limit sign. So this becomes 2 times 2 plus 0. But this is simply 4. So that was a coincidence here again. So the k value that we were looking for in this problem is again 4. Okay, so you see that finding the k value is somehow a tedious process. Yeah, so you need to do a lot of things. And by the way, you see that the function is quite a simple function. There is no trigonometry involved. There is no complicated functions involved. There is no fractions, nothing. But still, calculating the k value could be quite lengthy. And that's the point. The next part of the lesson, we want to learn how we can calculate this thing faster. But this is one of the main important topics, at least at the math level, at the matrice level. So to understand and appreciate the definition and to be able to find the k value. So if I want to, even if you want to calculate this k value later, it's just 2 seconds we can calculate this. I know the rule. If I want to, there is a notion called derivative. I take the derivative of this function. I know the rule. It becomes 4x. And instead of x, I put 1. 4 times 1 is 4. And that's the answer. Okay? But even, of course, we will study this later. But even at that stage, it doesn't mean that you don't need to learn that. Most of the time, we do the quick way. But there is questions in the book, and there will be questions in the exam that I will ask you to use the preliminary definition to find the k value. Then it means that you have to know this process. Okay? But the good news, I just want to tell you right now, the good news is that most of the time we can use some other ideas to calculate this. But that was the way that actually Newton and Leibniz were calculating derivatives. Mathematicians later categorized functions into different groups and discussed about these limits for those problems. Okay, but yes, let us just concentrate on this one today. We will come to them later. Do you have any difficulty understanding this process? Okay.
In the test, do I have, is it enough if I say the slope is equal to 4? Do I have to write k equal to 4?
No, it doesn't matter.
Okay.
Yeah. You can write the slope is equal to 4 because the slope is, it's better even, because I just introduced k assuming that k is the slope, but it is better to answer as far the slope is equal to 4. It's better. Okay, is the process clear? Okay, now let us go and give you another function. I want to wait a little bit for you because I want to make sure that you understand what's going on. Yeah, try to repeat these things a little bit for you. Don't be in a hurry in the calculations. I want to make sure that you know. Okay, so let me write another example here for you. We can increase the level later, but this is exactly at the level of the book. So f of x, let me change the function to another function. Let me stick to polynomials first. Let me write x squared plus 3x minus 2, okay? And then let me write the point of tangency is equal to, let us say, minus 2. And then I don't give this one, okay? Here, I gave you the second one. But the second one is actually not needed. Because if I give you, that's okay. But if I don't give you, I give you this, you put it yourself here, it becomes 2 plus 1 is 3. So in principle, if they give you this, they are doing some favor to you, they are saving some time for you. But if they don't give the second one, you are able to calculate the second one yourself. So yeah, I can just put a question mark here. That question mark, you can find it yourself. Okay, I think I can wait for 5 or 6 minutes to see how this goes. But the problem with live stream is that there is no pausing with a very clear reason, yes? So anyway, let us just wait. If you got the answer, can you just write it in the chat window for this YouTube to see how it works? The final answer for the k value.
K value?
Yes, yes. Euro 2. No, you have made a mistake. 2 is not correct. So let me double check. No, 2 is not correct.
Is it -1?
Yeah, -1 is correct, yes. Because you see that I am not using this long process. I know the rules, so I can calculate it just in very short time. I will teach you later, of course, but this is very important that you learn this thing as well, because later we will use this formula over and over again. Whenever we want to find a formula for the derivative of a particular function, we have to use this definition. So it's very important to learn this definition. Okay, I can write 2 more examples, but if you haven't finished that one, don't start the other one. So number 3, I can write, let me change the name of the function. This is not always f. So let me this time write g of x, and let me make it a little bit more tricky this time. So let me write 1 over x. Okay, and then let me give you t to be, for example, 3 and question mark. And the other function, let me call it s of x this time, for example. I will give it as a square root of x, and then I give t to be 4 and something. Yes? Yeah. You can also solve these two problems. Don't waste your time if you have already done this. But if you want to be on the safe side that you understand everything, yeah, please try to solve these two problems. If I haven't done any mistakes, the k value for this should be -1/9. And the k value for this would be 1/4. Let me double check. Yes, that is 1/4. And that would be -1/9. If you can get those answers, so it means that you are on the safe side. If you can solve these these problems that you see here, it means that you understood everything in this session, and you shouldn't be worried about what is coming next. Of course, this becomes a little bit harder and harder, but if you come with me, then you are always on the safe side from the exam and everything point of view.